Okay, so let's see, is a speaker online? So is Robin online?
Yes, I am.
Okay, brilliant, brilliant. So let's get started. Welcome back, everyone. So this is the mentor stream session at the Code Sprint, the May 2026 Code Sprint. So our next speaker is Robin White. Robin is with Geo Robotics, who are actively involved in the OGC API Connected Systems Standards Working Group. So Robin is going to present a tutorial and a walkthrough on binary encodings with OGC API Connected Systems. So Robin, over to you.
Absolutely. This will be a bit more walkthrough than tutorial, mostly as a byproduct of the fact that I don't have the number of sensors available to me that I would need to have a visual differentiation between a binary encoding and just any given sensor receiving observations. But we will work with what we have.
Okay, we see your screen.
Yes, I am. Is it going through right now?
Yeah, we can see it.
Awesome. Let's make it pretty. Slideshow. There we go. Okay, so this will be somewhat foundational, but hopefully there will be information that is useful to at least some people here. I'm going to assume some basic understandings of like connected system API broadly, but I'll have some slides that are fundamentals for the recording up during the process either way. Just general things I expect most of the people in this call to know already, what the OGC API is, things of that nature. What we're going to be talking about today specifically is going to be binary encodings, which is like part 5 of the connected system standards. And it is basically taking the SWI-JSON like data model and replacing that JSON encoded like SWI standard with binary outputs. And like what that's going to allow you to do is primarily focused on at scale production level systems. The larger the network of sensors that you are connecting to, higher the upkeep, more throughput. When you're using the like binary encoding abilities available within connected systems, you can kind of shave a lot of the overhead off. And it allows you to also do a couple cool things that I'm going to touch on in terms of parsing and like pulling directly from the schema instead of having to parse the schema and also going directly to memory for certain things, depending upon which yes, this is the right side. Depending upon which like thing you're using between protobuf or the like. Protobuf, I'm assuming everyone's aware, it's Google's language neutral like serialization setup for data structures, and you can, within the confines of the connected systems API for the, where did it go? There we go, sorry. Within the confines of the connected systems API, you can make some different choices about which one you use. The one we're going to be looking at, I believe, is protobuf through Python, but that is not a hard set. And I should also state for the record that all of the things that we're going to be going through are going to be active in development for us. So some of the stuff could change at any time, but it's what we are dealing with currently. Things that like specifically with protobuf as opposed to like your alternatives are going to be just the like token usage for its allowed token structure, your additional language options, and some of the like naming conventions from protobuf make it a little bit easier for this. Why you need to use one of these in general rather than going directly with the binary is it just makes your compatibility between different systems a lot easier. It also avoids like some like Indian mismatching that could occur if you're going directly with the binary, which is very like niche level concerns, but necessary because those would be returning valid errors, which can be a pain. This is a quick breakdown of some of the other serialization formats. Flat buffers would be more likely an alternative than Avro, but like again, binary encoding is a primarily big data focused tool, so it's not impossible. But yeah, the flexibility, one of the major downside of protobuf is it's the one of these that does still require parsing, but that is not an end all be all. This GitHub link, if anyone wants to grab it from the recordings later, is going to link to one of our part 3 builds that is active development, but it is a it maps to part 5 in part, so it's a good example and breakdown of some of the workflows available for this. And I'll be looking and pulling some code from that towards the end when I field questions as well. But this is just like the front page of the GitHub that's linked to there, and some documentation from it. But I'll go through that in particular later. Binary encoding generically, we're just taking the XML or JSON structures and replacing it with a basic like byte notation. You can see like on the right that I have a table that's just your equivalents for each serialization option. Like you have your normal string, so your label would in cap and proto be label at 1, flat buffles label string, so on and so forth. Again, I don't expect that to be surprising information, but just a visual representation of that. Here's where we get into some of this stuff. Like value for this broadly, as I mentioned, is going to be at scale. When you use the binary encoding, it's just reduction of bandwidth usage, first and foremost, excuse me. It is fractional for the payloads compared to the standard XML, and the schema can be cross-compatible with Java, Python, Go. It is by nature of being encoded in binary, compatible with a lot more languages than if you're having to parse from one to the other. Also, the schemas are dynamic, so you can add any given field to a schema when it's in binary encoding, and it will not break an existing reader in the way that can sometimes occur outside of that circumstance. Then, as I mentioned previously, it allows you to read directly into memory structures. You can avoid parsing not in protobuf, but in some of the other serialization formats, which is going to be very, very useful, again, at scale if you have like 50 sensors all sitting into the same node at the same time, that can be very, very impactful in terms of the overhead of that project. And just in general, it minimizes churn within multi-sensor or high throughput projects. If you have like a very, very sensitive system that you're looking at where you're getting thousands of observations a second, even if you don't have like hundreds of sensors, there's still like potential value depending upon the fidelity and type of data that you're pushing from one point to another with that. It also, unlike some side benefits that's relevant, is it allows you to increase effectiveness of otherwise slower languages and gives generally greater leeway in developing languages in what development languages you're using. So like what Sam was talking about, for example, with connected systems for Python, there's legitimate concerns at scale for that that are mitigated by using binary encoding. Just shaving a lot of the overhead from that broadly. In terms of current status of this and the next steps for like the part 5 implementation that we're personally working on is that it's still, as I mentioned, an active development project. And while the increased capacity it provides is a game changer for production level systems, I don't want to make it sound as though that's the only thing it can do. There are applications outside of at scale production. And then this is just a like call to there and call for questions. But before I do that, I will pull up some of this that I mentioned previously. So this is the like package construction for the part 3 that maps onto part 5 that I mentioned previously. And it's just a basic layout breakdown of the like, oh, go ahead. Sorry.
We just see the who wants to get involved slide on the screen.
That would be important for me to share the other thing then. Thank you for saying that. I think I had to stop sharing and share the separate side. I apologize that this is kind of ramshot. I don't normally use Teams, so I'm not the best at getting this to work correctly. Here, let's go screen 1. Wow. Pull this up. Does that work?
Yeah, we see your web browser.
Okay, thank you. So yeah, this is just the conceptual overview for the part 3 like documentation that I mentioned that maps onto part 5. But if anybody wants to go to this source at any point, it also has a quick installation and a quick start guide for some of the serialization options for cap and proto, for flat buffers through Python, through protocol buffers through Python as well. It'll also have like your encoding comparisons between those serialization options, and it goes into some of the like core differences as well. It is a decent sort of guide for kind of what your cost benefit analysis for some of this is. And it will also be relevant later on when one of my colleagues goes into more depth with the part 3 pub sub stuff, which will be a more in-depth breakdown. There's also the basic quick start one that I just showed. Yeah, I already showed that one. And that's generally what the basis for this is that it's just a at scale benefit for throughput and size. for data and making higher fidelity or higher quantity sensor systems less intensive, if that makes sense. And I can go back to here real quickly. As I said, there's not like a direct like code example I can run for it, because it would visually look no different than any other sensor, because I don't have like a couple hundred sensors to run at the same time and then show you all the like comparative difference in overhead. But if anyone has any questions about the like potential for it, I'm open to that. I recognize that this was a quicker overview than it was booked for, but there was a lot more time was spent on like the upcoming part 3 examination than this one, if that makes sense.
Sounds good. Okay. Yep. All right. Thanks, Robin. Thanks for an excellent presentation. Are there any questions for Robin or comments, either online or from the room? Let's see. I think that's okay. So I've got a question. So effectively, what we're saying is we can use protobuf as an encoding for the communication between a connected systems client and a connected systems server, effectively, right? Is that?
Yes. It is just replacing the XML structure with the binary equivalent. And you can use protobuf, flat buffers, CAPN, either of them work within the confines of it. The capacity is already there within the Connected Systems API. And the benefit of that is that it is just by nature, because like you're flattening how it is serialized through those processes, more compatible with a wider array of different systems. And okay. It also just is less overhead to intake.
Okay, so at the moment, you're looking at this primarily from the perspective of Sui Common. I'm just wondering about what implications there might be for SensorML as well. You know, whether this, whether there's a case study that might require, or sorry, a use case that that might require binary encoded SensorML and even a benefit, right? I mean, I can understand with Sui Common, it's the motivation is clear, but I'm just wondering about all the other all the other models associated with this, whether it could be beneficial to try protobuf on them as well.
I mean, I would default to saying that there's always benefit in trying. I will admit that it's less immediately obvious, but any system at a certain size would benefit from it. If, for example, you had something that you were aggregating a number of systems with through the OSH Connect for Python, for example, to make it a little easier, because Python has certain comparable speed issues that in and upon itself could be a situation in which, even if we're going through SML there, that it could be useful, but it is less immediately apparent compared to Sui Common.
Okay. Okay, understood.
Yeah.
Okay, any other questions or comments? Okay, so you said this will be the focus of part 3. Is that part 3?
Ian Patterson will be going through the part 3 stuff. This
Okay.
is
Okay.
contextual to that, but the part 3 stuff is really cool. I think y'all will be in for a treat for it.
Yeah. Okay. Okay, cool. All right. Well, there are no other questions or comments. Let's thank Robin for an excellent presentation, please.
Yeah.
Okay, so I think that is it for now. And the next